The next lab you will be completing in this class is Chemical and Physical Changes Part 2. In the previous lab, Chemical and Physical Changes Part 1, you collected qualitative observations to determine whether a chemical or physical change had occurred. In this lab, in addition to qualitative observations, you will be measuring quantitative data to determine whether a physical or a chemical change has occurred. In this lab, you will be using a Bunsen burner, and when there is an open flame in the lab, make sure any long hair is tied back and that loose papers have been moved away from the Bunsen burner. In this lab, you will also need to measure the mass of the chemicals in containers that have been in contact with a Bunsen burner flame. Because they have been in the flame, they might be hot. Before you can measure the mass of a chemical in a container, you should make sure the container is cool. You should be able to comfortably hold it in your hand before you bring it over to the balance. There are two reasons why we should not weigh hot objects. The first, if the object is very hot, it might break the balance itself. But secondly, when a chemical is hot, a chemical or a physical change may be occurring that is causing the mass of the chemical to change. We only want to measure the mass once the mass of the chemical has stopped changing. Part 1 of this lab involves determining the relative temperature of the Bunsen burner flame using a nichrome wire, which you'll be able to find on the cart, and a piece of copper metal. To start this part of the experiment, you will need to light your Bunsen burner using a striker, and you'll put the nichrome wire in different parts of the flame and observe what happens. Determine what the hottest part of the Bunsen burner flame is. Once you've done that, you can then put a piece of copper metal using tongs into the Bunsen burner to determine if heating a piece of copper is a chemical or a physical change. Once you are finished with part 1, you can turn off the Bunsen burner. Part 2 involves heating two chemicals and quantitatively measuring any changes to the mass that may occur. The first chemical you'll be heating up is magnesium. And to heat up the magnesium, we're going to use a crucible. This is a crucible, this is the crucible lid. You should first measure the mass of the empty crucible, and then add about 1/4 gram of magnesium ribbon. I'll add my magnesium ribbon to the crucible, put on the lid, and measure the mass once more. Once I'm ready to heat the crucible and the magnesium inside of it, I will need to find a ring stand. There's a ring stand. Onto the ring stand, you're going to put a ring clamp. Ring clamp will go on. You're then going to put a clay triangle, you can find one of these in your lab drawer, in the middle of the ring clamp, because it holds the crucible quite nicely. If your crucible does not fit into your clay triangle, you can bend it until it holds the crucible in a safe way. The crucible lid should be carefully placed on top of the crucible and the clay triangle, allowing air and oxygen to enter the crucible while you're heating it. You should heat the magnesium gently for 2 to 3 minutes at the top of the Bunsen burner flame, and wait for any chemical or physical changes to occur. If no changes occur after 2 to 3 minutes, you can turn off the Bunsen burner, lower the ring clamp and the crucible further into the Bunsen burner flame, and heat one more time, waiting for the chemical change to happen. After the chemical change has occurred, you should cool the crucible for at least 5 minutes until it's cool. You can cool the crucible right here in the triangle, and once it is cool enough to touch with your hands, you can take the crucible lid and the crucible bottom and any chemical still inside and measure the mass after the change has occurred. The second part of part 2 involves dehydration. You're going to be dehydrating this mystery blue chemical and determining the percent water inside of it. To do that, you will need an evaporating dish. You'll measure the mass of the empty evaporating dish, then put 2 to 3 grams of the mysterious blue chemical into the evaporating dish and measure the mass one more time. We will not be heating the evaporating dish on a clay triangle. Instead, we will be using a wire gauze. The wire gauzes can be found in the drawers on the side of your lab bench. You'll put the wire gauze on top of the ring clamp and the evaporating dish full of blue chemical on top of the wire gauze. You should heat gently for 5 to 10 minutes until a uniform color appears. You should then cool the evaporating dish and measure its mass. You can cool the evaporating dish right here on top of the wire gauze. You should be careful when heating the blue chemical. You want to do so gently. If you heat the chemical too strongly or too quickly, little pieces of chemical will pop out of the evaporating dish onto the lab bench, and it'll look like there's a little dusting of white particles. You want to keep all of the chemical inside of the container, so if any of it pops out, you're going to be losing mass in the wrong way. You'll need to start the experiment again. So you should heat very gently so that you're heating the chemical to remove the water, but not heating it strongly enough that the chemicals can pop out. You will continue heating for 5 minutes, letting the chemical and the container cool, and measuring the mass until a constant mass has been achieved. Between one mass, a heating, and another mass, there should be a difference of less than 0.01 grams. That means that all of the water has been removed from the chemical. If time allows, you can repeat any part of this experiment that you wish to collect more data. You will then dispose of the waste in the correct labeled containers in the fume hood. Return any borrowed items, like the wire gauze, the ring stand, and the ring clamp, Bunsen burner, to the appropriate places, whether it's a shelf, a drawer, or the lab cart. Wipe off your lab bench, remove your goggles, lock your drawer, wash your hands, and leave lab.